Hi guys, welcome back to the channel. This is Web3 Boy once again, and today we are going to be doing this CoinFlip challenge from Ethernaut. So let's just start. So the challenge, what the challenge is about, let's just read it. So it says this is a coin flipping game where you need to build up your winning streak by guessing the outcome of a flip coin, right? So they are basically flipping a coin, and every time it has an outcome, and when you guess the outcome correctly, basically you win the game, right? So to complete this level, you'll need to use your psychic abilities to guess the correct outcome 10 times in a row. So what we need to do is we have to basically guess the outcome correctly 10 times consecutively in the row, and then we might cross the level. And what they are saying is, see this question mark page above in the top right corner menu section beyond the console, right? So what I'll do is I'll just click it, and let's see, it says beyond the console, right? So you have to look beyond the console. So here is the section beyond the console, and what they say is use Remix IDE to write the code and deploy it in the corresponding network. Or second step is set up a local truffle project to develop and deploy the attack contracts, right? So what I suggest you guys should do is use the first step, that is Remix. Don't go for truffle project. I don't I mean I if you're just doing it for the blockchain auditing thing, don't do it on a truffle course truffle suit, but instead go on the Remix IDE and do it there, right? So here is the contract, and I have made steps on Joplin how I'll be doing it, and let's just do the walkthrough. The first thing we'll be doing is general review of the code. The second thing will be list of all the global variables. That is something which is important for this level to be completed, right? And the third point is why randomness can't be created using global variables, right? So this particular thing is all about, this particular challenge is all about randomness, and we'll just see it why randomness cannot be created using global variables, right? And the fourth thing is we'll discuss about how Ethereum generates the randomness, right? So these are the four things. So let's just first get a new instance. So we'll be getting a new instance right here, and I'll just confirm the transaction, and we'll have our own instance here. And the next thing is this is something new. This challenge is something new because it involves for us to write our own code, and when you are writing your own code for taking over the main contract, and basically you are writing an attack contract that goes and attack on the main contract, and basically for this particular level it guesses what the correct number is. So we have got our particular instance address. So what I'll be doing is I'll be just showing you await contract, and let's see, this is our contract address, right? And also I will show you await player address, right? So this is our player address, right? So what they are saying is, they are saying that you'll have to guess the correct outcome 10 times in a row. So when you'll be guessing the correct outcome 10 times in a row, you'll be submitting your instance, and the current level will be completed, right? So first thing is I want you guys to look at contract API. We will just look at contract API, and then we'll later on move on to the next section, right? And discussing the code. First, let's just look into the API, what API is. So we have API, we have this constructor function, we have this consecutive win function, and we have this I don't know, this is not a function, I guess. Consecutive win is a function. No, consecutive wins is just a state variable that is initialized to 0, and every time you you keep on guessing the right number, it'll just increment by 1, increase by 1, right? So this is what it is. And one more thing I want you guys to look at is this flip variable, right? So this is the flip variable, right? This is the flip function. So here it is the flip function, and this function is basically flipping the coin, right? So let's just copy. I have already copied the function. I'm not copied the contract. I'll not keep on copying in every video. I have copied the copied this contract. I'll just cut it. So here is the remix ID, and we have this CoinFlip contract. I have copied it from the main contract over here, and let me just show you what these functions do, right? What this contract is all about. Let's just go over through the code. So this is Pragma Solidity 0.8.0. You guys know it, that it is using this particular version of the Solidity compiler, and this again should not be this should be freezed in the deployment time, at the deployment time, right? And this is contract is CoinFlip, and here we have a consecutive wins variable, and this is a global variable, this is a state variable, and this is public and of type uint256. Then we have a last hash global variable, and it is basically uint256. Again, I'm saying a global variable and state variable. So this is state variable. This is also a state variable, right? So this is initialized to this particular number, and this particular number is basically, if you guys are thinking what this particular number is, this is basically 2 raised to the power 255, and this is it, and this will be basically used to generate a random number, right? So we have a constructor function. One more thing to look into this code is the constructor function here sets the consecutive wins to 0, which need not to be done. Why? Because we have a state variable set as consecutive wins, and when a state variable is public, it is automatically set to initialize to 0, right? So this need not to be done. I don't know why they have done it, maybe for the clarity purpose. And going on to the flip function, so we have this flip function that takes in a guess, and the guess will be bool. The bool will be true or false, so it takes in the guess and returns a bool. And here we have this particular line that says the block number -1. So what this block number -1 signifies is, let's say you have sent a transaction, let's say you have guessed the number, and that number is included in the block number, is mined in the block number, and that block number is not yet mined. So you have to go back to the previous block, right? So you have to do the block.number -1 to get the previous block from the current block, and then you'll have to hash it. So after hashing it, you will be converting it into uint256, and then you'll be storing it into the block value, right? And here what they are saying is, they are saying if the last hash is equal to block value, then revert. Then you need not to do anything. And if it is not true, then just store the block value into the last hash. And here they are saying is block value must be divided by the factor. The factor is this particular number. And one more thing is, guys, like this particular number is too big, and when the block value here when this whole thing is converted into uint256, it will give you a insanely huge number, almost equivalent to this, either bigger than this or smaller than this. So when you'll be dividing this block value divided by factor, either you will be getting a number lesser than 1 or greater than 1. If it is greater than 1, then the value will be like rounded off to 1, and if it is less than 1, then it will be rounded off to 0, because in Solidity there is no concept of floating point numbers. So if you have something greater than 1, it will be rounded off to 1, and less than 1 rounded off to 0, right? So if it is 0, it will be false. If it is 1, it is true, right? So bool side, so what this particular is a ternary statement, this is a ternary statement, and what this particular thing says is, if CoinFlip is equal to 1, then return 2, and if it is not equal to 1, then return false, right? And here they have their own logic, and they say if side is equal to guess, whatever the guess we are guessing is equal to this side, then if it is true, just increase the consecutive 1 by 1 and return true. Else, it will again, if you are just missing your correct guess a single time, the consecutive wins will be set to 0 once again. So this is it, guys. This is how the code is, and where the problem lies is, I was also stuck. The video I have seen, the guy I have seen, he was also stuck. I was also stuck. I could not figure it out where the problem lies actually, like how. And I read a lot of resources, and after finding that, I found out that this particular number, these numbers are basically the problem. These are the problems. Like if you have a factor, if you have this much of a big number stored in a global variable, a state variable that is accessible to everyone, right? So if it is accessible to everyone, anybody can guess the random number, then the random number is not random anymore, right? So the whole concept of blockchain is of decentralization, right? It is not of centralization. So if you have an entity that is that is generating a random number, and that is basically generated by a centralized entity, then that particular entity can basically manipulate the whole game, right? If there are certain games, like if there is a casino that says you'll win $1 million if you guess the correct number correctly, a random number correctly, but there is some guy who is from the casino and he knows the number already, so he can guess the correct number, right? So this is basically the random number is generated by the centralized entity, but not from the decentralized entity. And the whole concept of Web3 is of decentralization. It is basically, if something is it is of consensus, right? Everyone comes to a common point, and then the blockchain, then the block is mined, and then the block is included in the blockchain, right? Only if the consensus is made, right? And there is no, if you go to the Oracle manipulation problem, if you search for the Oracle manipulation problem, you'll search about it. You'll get it, like what the problem is. So as far as I know, I have researched, there is you cannot, why randomness can't be created using global variables. I will just one more thing, I'll show you what are the global variables and how many global variables are available. So this is the link I have found, and all the block hash, and see here, block.chain ID, you can get it. It is globally available to anyone in the Solidity itself. Block.coinbase, it is globally available to everyone, right? So these are basically block.timestamp. These are basically the global variables. I might have been saying state variables, but these are the global variables, right? So here we have in the code we have this last hash, which is a global variable. So if you are using a global variable to determine the randomness, it is not random anymore, because global variable is accessible to everyone, right? So the problem is this, right? So we have again, like, how can you guess the, I mean, if they have made this logic and they can guess, they are about to produce a random flip of a coin, and you have to you don't know, right? So how do you know? You just implement the same logic with the same global variables, with the same contract address. You'll definitely get what they are going to produce, right? Either it is tails or heads, right? So the whole idea is to guess the correct coin flip. And how you'll do it, you'll just copy the whole contract. You have accessibility of the global variables that they are using to generate the randomness. So you have the accessibility of the global variables. So if they can generate a random number, you can also just copy the same random number, and you can also generate it. You can guess it correctly and then submit it, right? So that is what we are doing right here. So we have written, so I have written, not I have written, I have, like, I generally just copy pasted this, because this is the first time I was writing this, so I could not like figure it out. So what I did is I just watched it over the internet and copied it, right? I'm not going to I mean, right in front of you, so that you guys, like, the guy also said the same thing, that you don't have to write in front and pretend that you are writing. So what blockchain auditors are doing, they are basically finding the bugs, right? They're not writing the codes over there. So they are finding the bugs and thinking about the potential exploits. So that's what I'm doing right here. So I'll just, this is the attack coinflip.sol that I have copied, and I'll just take you through the code and explain you what these are, right? So this is pragma solidity and everything, right? So we are importing the coinflip.sol. So we have here coinflip.sol. So I'm just importing this from here, and I'll make a so here we have made a contract that will be attacking on the main contract, that is coinflip.sol. And here what we have done is we have like, this is coinflip type, this is public, and this is coinflip variable name, right? This is variable name. So what we are doing is we are basically let me just show you coinflip. So here the name of the contract is coinflip, right? So we are just bringing this variable is of type coinflip. That means we are bringing that contract over here, and this is of contract type, right? So, and we are copying, we are just pasting this particular factor also, because we know this factor, right? If they know this factor, we also know this factor, right? And we have made a constructor. This is constructor, and we have an address type of underscore coinflip. That coinflip means I mean that this is underscore coinflip, and here we'll be putting in the contract address of this coinflip. Okay, so when we'll be putting the address of this coinflip, we are basically generating a new instance of the same type as of this coinflip, right? The previous contract. So what we are doing here is we are putting in the address of the main contract, and this is of type this coinflip, right? So this will basically give the address, this will basically give the whole ABI, and when the address is combined with the ABI, it will give the contract, right? So we have the contract, and we will save the whole contract into the coinflip variable, this coinflip variable, and it is of type coinflip, right? I hope you guys are understanding it. This was very confusing to me when I was first starting, but right now I'm getting the hang of it. So I'm hoping you guys also will be getting the hang of it later on, right? Just don't drop it in the middle of nowhere, right? And later on we have this constructor function that will be producing the new instance of this particular contract, right? So we have the instance of the contract. Now what we'll be doing is we will be making our own flip a flip function, and this function is flip function, and then this will be public. And what the logic in here will be same as in the coinflip.sol, right? So what we are doing is we are just copying this particular line, and then we are pasting it over here. So this is the same logic as in the previous contract, and again we are dividing this block value by factor and then storing it into the CoinFlip, and again the same ternary statement. And last thing is, whatever this flip function will be giving, we will be taking from this CoinFlip, and the function, we'll be taking this CoinFlip and we'll be accessing the flip function, and then we'll be passing the side, whatever the side they have been producing, right? The initial contract has been providing. So this is the side, here this is the side. So whatever the return value of this will be, so we'll be getting it over here, right? And we'll be storing it into the flip function, and then we'll be getting whatever the true result is. So I hope you guys have understood what we are going to do. And then I'll just what I'll do is I'll just coinflip.sol, I'll just deploy this particular contract, coinflip.sol, and when this contract is deployed, all we have to do is we'll have to keep on doing it 10 times. But before that, let me just show you one thing pretty fast, otherwise await contract dot consecutive wins, right? I'll have to show this, otherwise. Okay, so this is await contract dot consecutive wins. Initially the consecutive wins will be 0, right? So this is confirmed transaction, so this is 0. So when you'll see into the words, it will show that at 0th element the value of the element is 0, right? So the consecutive wins is 0, initialized to 0. And here we have coinflip.sol. okay, this is deployed. And second thing what we'll be doing is we'll be just deploying this, but this is the constructor function. So what this constructor function is taking right here is the address of the contract, right? Initial contract. But what is the initial contract in our case? In our case, I'll be doing await contract, right? So this is the contract address, and we'll be attacking this particular contract, so we need this address, right? So I'll be copy pasting this address in the constructor function. Here I just deployed it. So what this will be doing is I have taken the initial I have taken the original contract address. Let's just confirm it. I have taken the initial contract address, like original contract address, and I have passed it as a parameter in the constructor function here, right here, and this will give us the instance of the original contract, right? So we have the original contract right now here. So what we will be doing is we'll be just flipping the first coin, right? So this is the first coin we'll be flipping. So we when we are flipping here, we are just guessing the number correctly, right? Guessing the flip correctly. So transaction is confirmed. Let's just see if consecutive wins has been increased by 1 or not. So here in the words, when you'll see here, the length is increased to 1. Initially it was it was length, in the words length was 0, but now in the words length is 1, right? So it is increment, it is increased by 1, right? So next time what you will be doing is you will be flipping it again, right? So if you flip it again, it will just increase by one more time, right? So the number in the words will be increased by 1. So it will be, right now it is 1, you will be getting 2 in the next flip. So let's just keep waiting for the flip, otherwise it will not be updated. So it is confirmed. I'll just show you what the what the consecutive wins is at right now. So it is again increment, it has been increased to 2 right now, right? So you will have to keep on doing it 10 times, and the contract will be it will be increased till 10, and then you'll submit it, right? So I'll just fast forward it right here and keep on doing it 10 times so that you guys know, I'll show you at 10. It was very tedious task, guys. So it was like, it took me forever to keep on doing this, and I'll just keep you guys, I'll just tell you guys that, keep on doing this continuously for 10 times, not more than that, and just submit it as soon as possible. So here we are, we have this 10 transaction has been done, and if you see here in the words column it says 10. So we have basically found 10 consecutive transaction. We have correctly guessed the 10 consecutive transactions and flip of the coin. And what now I'll be doing is I'll just be submitting this instance, and let's see if the instance is submitted or not. So this was very, it was toughest for me till now, and because it needs for me to make a contract that is of a tag type, and it was tough for me. So okay, here we have completed this particular level, and congratulations to me, congratulations to you guys if you have been following along, and I'll see you on to the next video. But before moving on, I'll just ask you guys to keep on, I have this list of some of the medium post, and some of this random, how Ethereum generates randomness, like list of all the global variables, and these are must read for you guys. Like before just watching the video, keep your research ready, and just dig in a little bit more, and tinker around within the contract and contract code, so that you guys know in and out of the code whether you are able to crack the code or not, whether you are able to find the bug or not. That doesn't matter. But before moving on, and before before just cheating right away, I suggest you guys to please just keep on hustling a bit more, so that ins and outs of the contract, right? So here it is, guys, we have completed this particular level, and that's it for today, and I'll be seeing you in the next challenge, and the next challenge is, I guess, this telephone, right? So I'll be seeing you in the next challenge. Until then, bye bye, guys.